Okay, so up until now in this project, we've been comparing the height of our gold medal winner in each division, the female and the male division. We've been comparing their heights to the silver and bronze medalist heights in their own division to see if height is an unfair advantage. So that's what we did on question 2 when we saw the proportional distance. So here on question 2, these proportional race distances are compared with the gold medalist, Elaine Thompson. So because the silver and bronze medalist, I'm doing this for the Tokyo Olympics 2020 for my example, because the silver and bronze medalists are taller than the gold medalist, their proportional races ended up being even longer. If they were shorter than the gold medalist, then their proportional races would be shorter. And then we did the same for the men's division. We had Andre De Grassi was the gold medalist winner, and we compared the silver and bronze medalists, their heights to his to find their proportional race distance, which was these two numbers, which are also longer than 200 meters because they were taller. So now what we're going to do on 6 is we're going to act as if everyone is in one division, as if there isn't two divisions, a female and a male division. And we're going to calculate the proportional race distance based on height for all 6 competitors compared to the fastest competitor out of all 6. So we're going to combine the two divisions and see the results. So I will walk us through that. So the first thing you're going to do is you're going to look and see out of all of your competitors, and this is on your original results. You don't need to look, you just use this spreadsheet for that. You're going to see who has the shortest time of all the competitors. This is the fastest competitor in the original race. For me, it's Andre De Grasse, who has the smallest time out of all 6. So I'm going to take this competitor, the fastest one out of all of them, and I'm going to put them in the first row here. And then their speed, I'm going to take from question 1. And everyone's speed on question 6, we're going to take from question 1. And then here in my first row, I'm going to put my original race distance, which is 200 meters. And then I'm going to use the original time, which was 19.62 seconds. So this first row is mostly just information from the packet, or not the packet, the spreadsheet. So fastest competitor, their speed, the original race length, and their time. Then you put the silver medalist. You don't have to do it in this order, but I think it's the way that makes the most sense. You put the silver medalist from the same division. So in that case, this would be Kenneth Bednarek. So I put them there. I'm going to grab their speed from question 1, 10.16 meters a second. 10.16 meters a second. And then I'm going to grab this person. So I've already seen the proportional race distance between, if I compare Andre De Grasse's height and Kenneth Bednarek's. It's what I calculated here in question 2. So this is where you'd grab your information from question 2 for the silver medalist for that division. And you're going to put it here. And then you're going to get their race time from question 3, because that is their proportional race time, and you're going to put it here. So far, this column I'm going to take from question 1, this column I'm going to take from question 2, and this column I'm going to take from question 3. And my first 3 rows on question 6, I don't need to do any new math, because I already compared these competitors to the gold medalist in their division. So then I'll do Noah Lyles, bronze medalist in this division, put him in row 3, grab Noah Lyles' speed from question 1 to put here. Oh, 21.130 seconds is not what I want there. Noah Lyles. Then I grab the proportional race distance for Noah Lyles from question 2. and then the proportional race time for Noah Lyles from question 3. So the first 3 rows of this, I don't need to do any new math. I'm just collecting what I'd already done for, in this case, the men's division. So now is where the new math comes in. So now I'm going to treat all 3 of these competitors as if they were in the same division. So I'll start with Elaine Thompson. Again, it's not required to do it in this order, but I think it makes the most sense. Put Elaine Thompson there. So I can grab Elaine Thompson's original speed. Everyone's speed stays the same throughout the entire event or the entire project. So there's Elaine Thompson's speed. But now what I'm going to do is I'm going to take Elaine Thompson's height and compare it with Andre de Grasse's to find Elaine Thompson's proportional race height. So I'll show you what that means on Jamboard. So this is going to be like you did earlier in the project. We're going to take Andre de Grasse's height, which was 1.76 meters. And where are my Jamboard's not linking up? Just give me 1 second. See if it'll write now. Yay, okay. So I'm going to take the height of my fastest competitor, which for me was Andre de Grasse, 1.76 meters, and my event length, 200 meters. So I have 1.76 over 200. So this is the ratio that I'm using to compare all the other competitors to. It's the one that I'd already used for my competitors in the male division on questions 2 and 3, and it's the one I'll now use for the competitors in the female division. So I have 1.76 over 200, and then I'm going to use Elaine Thompson's height, 1.67, and that's going to be over X, because that's going to be Elaine Thompson's proportional race distance. And that's what I want to figure out what it is. So now I'm going to cross multiply. So I'm going to take 200 and multiply it by 1.67. So you can use a calculator here. So you do 200 times 1.67. It's going to be 334. 200 times 1.67, 334. So I'm going to write down 334. And that's going to be equal to, 1.76 multiplied by X, which is just going to be Elaine Thompson's proportional race distance. We just don't know what it is yet. So that is, as of now, just 1.76X. which means 1.76 multiplied by X. So now to figure out what X is, we're going to take everything and we're going to divide it by 1.76. So I take 334 and I divide it by 1.76. And I get 189.77. I'm going to round to the nearest 100th, 2 decimal places. So 189.77. So that's going to be my proportional race length for Elaine Thompson, 189.77 meters. And now to get Elaine Thompson's new race time, I take this number, Elaine Thompson's new race length, and divide by Elaine Thompson's speed from question 1. So 189.77 divided by 9.29. Go. 189.77 divided by 9.29. And I get 20.43 seconds. Okay, so 20.43 seconds. So that's Elaine Thompson's new race time. So now I'm just going to do that same exact process for the silver and bronze medalist in the female division. So I'll take Christine there. I'm going to get Christine's speed from question 1 there. And I'm going to go back to here. And now I'm going to do the same process, but I'm going to put Christine's height up here in the top right, which is 1.75. Okay. 1.75. And so now Christine is actually very close in height to Andre. And so this is going to be very close to 200. I'm going to do the same thing, do 200 times 1.75 now, which is going to be 350. So I'll have 350, and then I'm going to do 1.76 times x, which is 1.76x. So now the only difference is I'm going to have 350 equals 1.76x and divide by 1.76. So come here, 350 divided by 1.76, and I get 198.86, and that's going to go here, 198.86 meters. And now to get this value in column 3, the new race time, you can take 198.86 and divide by this number, my speed, 9.17 meters a second. So I divide the meters by the meters a second, and I get the seconds. So now we'll go 108.86 divided by, it's 9.17. We had 21.69, which is going to go here, 21.69 seconds. Okay, and now I only have one row remaining. Gabrielle Thomas, who's going to be the very bottom right here. I'm going to grab Gabrielle's speed from question 1, 9.14 meters per second. I'm now going to find Gabrielle's new proportional race length. So I have to get her height, 1.78 meters. Go here. So now I'm at 1.78. And so Gabrielle is actually taller than Andre. So her race length is going to be a little bit over 200. It's going to be more than my original race length, 1.78. Okay, so now I multiply 200 times 1.78 and 1.76 times x. And those values are going to be equal to each other because that's when I cross multiply. So 200 times 1.78 is going to be 356. And then 1.76 times x is going to equal 1.76x. And then to find out what x equals, I'm going to divide the whole thing by 1.76. So I get 356 divided by 1.76. And I get 202.27. So that's going to go here, 2.27 meters. And then I'm going to divide this number by my distance by my speed to get my seconds. So 202.27 divided by 9.14. And I get 22.13 seconds. Okay, so now I finished question 6. And I like to look through it now and label look at my times and put them in order of who would be first to last now to see how much different my results are. Because in my original results, this was the fastest, second fastest, third, fourth, fifth, and sixth fastest. So now I'm going to see if anything changed. So if I look at all the times, Andre is still number 1. He has the least amount of seconds to run the race. Now my new number 2 is actually going to be Noah. And then now my new number 3 is going to be Elaine. Then Kenneth comes in 4th instead of 2nd. Christine comes in 5th again. And Gabrielle comes in 6th again. So my results did change a little bit, mostly that Kenneth dropped down and Noah and Elaine moved up. So my results didn't change a whole lot. Some events, they change a lot more. And the reason why is if you look in my event, my gold medal winners were the shortest ones out of the 3. And this project tests if height is an unfair advantage in track and field. So in an event where the shortest racer is in first, it doesn't seem like height is an unfair advantage. But in other events, the taller racers seem to do better. So it'll be different for each event.